Miss Medrano, and I'm here to talk about Ohm's Law Lab, the introduction. And so in that one slide that talks about the Ohm's Law Lab introduction, you should have a link to this simulator, which is, you can find it on Physics Classroom. To resize it, you can go down to this corner and drag it so that it gets bigger. Or you can also click on this, but it'll just make it bigger and take up your whole screen. So if that's what you want to do, you can do that. But I'm going to just keep it here at this window. I think it's big enough for you to see it. So we're going to use this to take quantitative data. So that means that we are going to get numbers to see how the current, voltage, and resistance are all related in a circuit. And so a couple things that we've learned so far is that a circuit is complete when all parts of it are in a continuous conducting path. So that means that the circuit needs to be closed and all the materials in the circuit need to be conductors. Okay, and so once I closed it with the light bulb, you can see that the light bulb turned on and all the electrons immediately started moving. The battery, so I'm going to click on the second tab under the pencil. The battery provides a push or a voltage difference, causing already existing electrons, which is the charges, when we're talking about conventional current, to move. All right, so once we connected everything, the battery caused the electrons to move. Okay, the movement of the electrons can be characterized as current, which is the rate of the current flow, or the charge flow, sorry, the rate of the charge flow. And we're going to use the ammeter right here, the one with the box, to measure how what the current is. And so according to this, our current is at 0.9 ammeters or amps. The battery, if we want to find out how much the battery is, the batteries, when we click on the battery, and there should be a magnifying glass that shows up, it is at 9 volts. And so we can increase by 1 when we click on the arrow to the right, up. Okay, and we can decrease if we click down. We can also increase by tens if we want, and then we see some sort of difference. And so you should see when you click on the battery that the ammeter will change also. And so at 20 volts, it's at 2 amps. Okay, and then the resistance, so we're going to go back to the pencil to edit. The resistance is defined as how much the charge flow is hindered and is dependent on the properties, the thickness or the length, or the composition of the material itself. So whatever the resistor is made out of will affect the resistance. And so in this lab, to find out how much the resistance is, we're going to click on the second tab again, and we see that the magnifying glass is on the battery. So we're going to go ahead and click on the resistor, and we see that the resistance is at 10 ohms. And when we increase by 1, we see that the current also changes. And when we increase by tens, we can also see the current change. All right, and so you can play with this for a few more minutes and make sure you know how it works. And you're going to have 3 things you can measure and change. And so I just showed you what those 3 things are. So the battery, click on the battery to get the magnifying glass, and you will read it right here in this section. And you will read the current when you change the battery. So for part 1, you're going to change the voltage, read the ammeter, and then keep your resistance the same. For part 2, you are going to change the resistance by whatever number you want. Okay, and you are going to read the ammeter, and then you're going to keep the voltage the same. So that's for part 2. All right, and that is it for the Ohm's Law Lab introduction.